Hello everyone, I am Deep Lakshmi working in TNEB as Assistant Engineer at Coimbatore. So my presentation is based on obtaining absolute negative resistance in a modified ferrite inductor like structure, which will also be a source for infrared. So flux tube. So what is flux tube is nothing but a cylindrical tube like structure where inside the magnetic flux lines will be flowing, and at every plane or every line everywhere the magnetic flux lines will be parallel to the cylindrical sides of the tube. As you can see here, this line is parallel to the side of the tube and there is a bend here, therefore the magnetic flux line is always parallel, therefore it also bend like this parallel to this edge, and also here it's parallel to the sides of the tube. So the flux lines will be flowing according to the continuity equation, which is given by A1 V1 is equal to A2 V2. A1 is the cross-sectional area here, and A2 is the cross-sectional area here, and the V1 is emerging velocity, and the V2 is the flowing velocity towards A2. So area and velocity are inversely proportional. So this is the continuity equation. So how this area and velocity is related and how pressure can be incorporated here. So according to the conservation of energy and also continuity equation, pressure and velocity are inversely related to each other. So in electrofluid dynamics analogy, pressure is directly related to potential and velocity is directly related to electric current flow. So as you can see in the power transformer, the power is constant, and based on that the voltage and current will be mutually coupled to each other. If voltage is high, the current will be low. The voltage is low, the current will be high. So based on that analogy, the pressure and the velocity will be related according to energy conservation. So the previous continuity equation can be modified by incorporating the pressure term. So let's move on to the next slide. That the new continuity equation will be P2A1 is equal to P1A2. Area and the pressure are directly related. So P1 is the pressure along this cross-sectional area A1, and P2 is the pressure on the cross-sectional area A2. So A1 is small, A2 is large. Therefore, the pressure will be smaller here and the pressure will be higher here. So the flux lines are moving from low potential gradient to high potential gradient. It is flowing against the potential gradient. So that's the concept of this flux tube. So based on this topology, designing the inductor, that is I am naming as unique inductor topology. So according to the law of continuity equation, as you already saw, and as in fluid dynamics analogy and electrical term in this I am applying. So this is a cylindrical inductor with a non-uniform cross section with the coils wound around it, and the flux lines are flowing from here. So cylindrical inductor with a varying cross sectional area and applying DC bias to the coil, resulting in short circuited inductor. And P1 is the pressure here, P2 is the pressure here. They are directly related to potential term, and A1 is the area here, A2 is the area here. So what are the characteristics of this inductor? So it is a cylindrical ferrite core inductor. As I already saw, area cross-sectional area A1 is actually less than cross-sectional area A2, and DC resistance of the ferrite core is of the order of milliohms, morely closely to short circuit resistance in most cases. DC current is injected into the core through a DC voltage source or DC current source, and also as there are no frequency component here, I am injecting only DC. The core losses are mostly frequency dependent, therefore they are negligible. There will be no drop across the inductor, therefore the potential will be, there will be no potential drop in this area. But the interfaces have different potential. Here it is low potential, here it is high potential. Therefore, it is flowing from low potential to high potential. It is flowing against the potential gradient. Therefore, there will be negative resistance at the interfaces. And based on that, we are actually obtaining this absolute negative resistance in this case. Okay. So I'm actually, this figure can be illustrated as in I can explain in the next slide with the use of next slide. Let's move. So the flux lines will be like a conveyor, the conveyor belt, and pressure at A1 is actually low and pressure at A2 is actually high. And I am injecting electrons. So the electrons will be transported from low potential to high potential with the help of magnetic field here. So the magnetic field is not doing any work. Whatever be the upward motion is balanced by the downward motion. Therefore, the magnetic field is not doing any work, except it is just transporting the electrons from low potential to high potential. Just like flux causes induction in the secondary coil in the power transformer. So it's like similar to that. So this is my illustration. Simple illustration. So the magnetic field is like a conveyor belt. The electrons are flowing from low potential to high potential. I'm injecting the DC current here. Therefore, the electrons are flowing like this. So it's experiencing a motion. So this is the concept. And how it is going to be a source for radiation. So in this, in the reference I cited here, the resistance emits heat. Normally, the resistance is just considered to be a source for infrared radiation. It dissipates heat according to Joule-Lenz law. So, according and based on that, I am telling this negative resistance will be a source for infrared radiation, which will generate oscillations in the infrared range. So, that will be the source for infrared radiation based on normal concept, based on the basic concept only. So, this is the next slide. So conclusion and future research. So I obtain negative resistance and is also a source for infrared, responsible for oscillations in the infrared frequency range. So it is considered to be a source for radiation. So this is just a qualitative and theoretical analysis. It can be developed further quantitatively by performing experiments. So negative resistance can open to new ways in electricity power generation. Thank you. These are the questions.